It's your friendly math tutor, Miss C here, talking today about sinusoidal functions, also known as sine functions or sine waves. So here we have our sine function. It does really look like a wave. So a couple things about sine functions before we get started solving problems. First, the maximum value for a sine function, so that's y equals the sine of x, is 1, and the minimum value is -1. On this graph, we are operating in degrees, though you can certainly look at graphs of sine functions in a measurement called radians. So in this case, our x values are in degrees, and our y values are always going to fall between -1 and +1, inclusive of both numbers. Here are some other things that are really important to know about sine waves. First, the sine wave repeats itself every 360 degrees. So if we look over here, like I like to start at 0. So if we follow this wave all the way down and then back up, we hit 0 here, and then our wave begins again. And it does the same thing if we're coming this way. It starts up and then goes down and then hits 0 again. So you might notice that 360 degrees is the measure of a circle. So we are operating in 90-degree increments. So for sine, at 0 degrees, our value for y is 0. At 90 degrees, that's right about here, our value for y is at 1. So that's its highest point. At 180 degrees, we drop back down to 0. Then we drop down to -1 at 270 degrees. And then we pop back up to 1 at 360 degrees. And then we repeat the cycle again. So let's now look at something that makes sine a little different from cosine. And that is that the sine wave has two x values with the same y value within every 180-degree increment. So when I'm looking at 180 degrees, I have these purple lines, right? This is 0 degrees and this is 180 degrees. And if I were to draw horizontal lines across, you would see multiple y values with multiple x values with the same y value. So here's an example of two y values that are the same. Like if we connected those with a line, they would have the same y equals value, but very different x values. So this is really important when we solve equations, because we only get one of these solutions when we solve the equation, and we have to find the other one, and that's based on the fact that two values occur within 180 degrees. The same is true when we look at the other side. So if we look at the 180-degree distance here, we're also going to have two values that have the exact same y value but different x values. And this is true for every 180-degree increment on this graph. And finally, the other thing that is really interesting about sine waves is every value repeats every 360 degrees, because the sine wave itself repeats every 360 degrees. So this value is going to happen exactly 360 degrees later, which is like slightly off the graph over here. These are all really important factors when we solve sine functions. Let's solve our first sine equation. So you're going to notice that the domain given is that x is greater than or equal to 0 degrees, but less than or equal to 360. That means we are looking only in this area. So I'm going to go ahead and draw our domain on this graph. So we're going from 0 to 360. We are only looking at solutions in this range, or within this domain is the technical term. So remember, sine waves go on infinitely, and we could have an infinite number of solutions. So that's why our problems always tell us where we're finding our solutions. The other thing that is something to notice is that we're looking at the places where the sine of theta equals 2/3. So I've put a blue line on this graph, and that is the line of y equals 2/3. Okay, so what that means is we are going to be finding solutions where this line intersects with our sine wave. So I can see that I only have positive values from 0 degrees to 180 degrees. So that means that our solutions have to be in this area. And more specifically, they have to be the 2 points that intersect with 2/3. So I have one intersection point here and one intersection point here. And that's where we should be finding our solution. So now that we know where we're going, let's go ahead and start solving. So my goal is to get theta by itself. And the way I unhook sine from theta is I take the inverse sine, sometimes we call it the arc sine of both sides. So when I do that, I end up with theta equals the inverse sine or the arc sine of 2/3. Okay? Back in the day when I was in school, and I'm not that old, we had to use books to do this because we did not have calculators. Now you're going to find the inverse sine button on your calculator and then put 2/3 in the parentheses. When you do that, you're going to find theta equals 41.8. And as a reminder, this measure is in degrees because we are in degrees. So that would be this point right here on the graph. If you remember when we started this particular topic, I talked about how sine has two values within 180 degrees. So the way we find this value is by saying that theta also equals 180 degrees minus 41.8 degrees. When we do that, we get a solution of 138.19 degrees, and that is this point right here. So our two solutions within the domain 0 to 360 degrees are 41.8 degrees and 138.19 degrees. Let's try another problem. Problem 2, we have the same domain, so I'm going to go ahead and mark that off here. So 0 to 360 degrees. This time, though, we are looking for a value for y values that have negative 1/5 as their value. So we are looking where our y values are negative. So that would be this part of our graph right here. And once again, more specifically, we're looking at where our sine wave intersects with the graph of negative y equals negative 1/5. So here and here. Boy, that point is not very accurate. We're going to do the exact same thing that we did before. We are going to take the arc sine of both sides. So I'm going to show that I'm doing that here by saying I'm taking the arc sine or the inverse sine. When I do that, I get alpha equals the arc sine of negative 1/5. When I pop that in my calculator, something really interesting happens. I get a negative number, negative 11.54 degrees. This is not one of our solutions because it is not within our domain. So this is where the rule that I talked about before, where our sine wave repeats every 360 degrees, comes into play. So to find our first solution, we are going to use that property and we're going to say negative 11.54 plus 360 degrees gives us our first solution. And that solution is 348.46 degrees. Okay, that puts us clear over here. Okay, that is that point. Now, like we did last time, we know that we have two solutions within this 180 degree domain or interval. So I'm going to go ahead and find my other solution doing exactly what I did on the last problem. I'm going to say that alpha equals 180 degrees minus, and I'm going back up to this value that I started with, negative 11.54 degrees. When I do that, I get alpha equals 191.54 degrees, and that value is right here. So these are the two values where the sine of alpha equals negative 1/5. All right, we are moving on to a problem for which we do not have a graph. We are using the domain 0 to 360 degrees again, and we're solving the sine of beta equals -4/5. So if I were thinking about this, and I didn't have a graph, which is likely going to be the case, I know that my sine wave looks something like this, right? And I know that when y is -4/5, it's down in this region somewhere. And it's probably pretty close, like -4/5 is -0.8. So it's probably somewhere in here. So I'm really looking for a point that's here and a point that's here, remembering that this is 180 degrees and this is 360 degrees. Ooh, that was not the smartest writing utensil. 180 degrees. This is 360. So let's go ahead and have at it. We're going to start by taking the arc sine, or the inverse sine of both sides. When I do that, I end up with beta equals the inverse sine of -4/5. I'm going to pop that in my calculator, and when I do that, make sure that your calculator is in degree mode, which hopefully it is, because this is the third problem we're now doing together. I end up with -53.13 degrees. Like the last problem we did, this solution is correct, but it's outside of our domain. So we need to find the solutions within our domain. So that means between 0 and 360 degrees. So the first thing I'm going to do is I'm going to add 360 degrees to this value, because we know that this value will repeat exactly in 360 degrees. When I do that, I get 306.87 degrees. So that's one of my solutions. Okay, and now I need to find my other solution. So I'm going to use this value again, but this time I'm using my rule that says that we get two values within 180 degrees. So what I'm going to do is I'm going to say 180 degrees, take away my initial value, which is -53.13 degrees. And when I do that, beta equals 233.13 degrees. Now, we don't have a graph, and you don't have me necessarily on your test telling you, yes, those are right. So here is what I recommend you do once you have found the answer that you think is correct. In your calculator, again, make sure it's set to degrees, and I'm going to type right into my calculator the sine, not the arc sine, not the inverse sine, just the sine of the degrees that we got here. So the first one, I would type that into my calculator, and it should give you approximately -4/5 or -0.8. It's not going to be exact because we rounded, but it should be really close. I'm going to do that again with my second value. So I'm going to type in the sine of 233.13 degrees. I should also get out a value very, very close to -4/5. If you do not get a value close to -4/5 or whatever value you're trying to solve for, it means that you've made a mistake and you need to go back and check your work. We're going to try one more problem in a different domain, a bigger domain, next. All right, our last problem. So we are solving in a different domain this time. We are looking at the domain from -360 degrees to +360 degrees when sine of x equals +0.9. So I'm going to just draw our graph here. So we've got our x-axis, we've got our y-axis, and we know that the graph looks like this. Oh my gosh, let me try that again. Let's get a little overzealous there. We know our graph looks something like this. And then on this side, it does the exact same thing. It should look exactly the same, but clearly I don't have the drawing skill. So something like that. Okay. So what we know is this is -360. This is +360. I'm going to label those. Okay. It's +360. We know that we're looking for values where y equals 0.9. I'm going to draw that line, and I think it's really close to 1. Okay. Perhaps that highlighter's too thick. but it's somewhere there. So what I do know is I have one, two, three, four values. So I should be getting 4 solutions out. So let's go ahead and start by taking the arc sine or the inverse sine of both sides. When I do that, I get x equals the arc sine of 0.9. When I pop that into my calculator, I get out a value that x equals 64.16 degrees. This value is within our domain. It's this value right here. So we know that that is one of our values. Okay. At this point, we have a lot of different options for how we find the next value. I am going to go ahead and choose to apply my 180-degree rule. So I'm going to say x then equals 180 degrees minus 64.16 degrees. And when I do that, I get that x equals 115.84 degrees. So that is my other solution. So now I found the 2 solutions where the x values are positive. Now I need to find the 2 values where the x values are negative. Remember that the sine wave repeats exactly every 360 degrees. So what I'm going to do now is I know that in 360 degrees, moving in the negative direction from 64.16, I have another value that makes this true. So I'm going to come down here and I'm going to say x equals 64.16 degrees minus 360 degrees, because I know that I'm going to have another value 360 degrees in the other direction. So that's why I'm subtracting 360 from 64.14 instead of saying 360 minus 64.14. I'm trying to find the distance from 64.16 360 units to the left. All right, when I do that, I get that x equals negative 295.84 degrees. I was really talking with my hands there for a second, and you couldn't see it because all you can do is hear me. So we are going to do the exact same thing with our 115.84 degrees. We know that we have a value here, and exactly 360 degrees or 360 movements left is another value. So we're subtracting 360. When I do that, I get negative 244.16 degrees. So let's just reason this out for a second to make sure that this seems reasonable before we check our answer. So we know, using our knowledge of the sine wave, that this is negative 180 degrees where it touches the x-axis. Both of our answers are smaller than negative 180 degrees, but bigger than negative 360 degrees. So these 2 answers seem reasonable. Now, you probably know what I'm going to say. Check your answer. Pop these into your calculator and make sure that you get approximately 0.9 out. So as a reminder, to check your answer, you are going to say the sine of, pick a value. You should do this for every value, but pick just one. To start with, 295.84 degrees. Make sure you're in degrees and not radians. And you should get, I'm going to say approximately 0.9. I checked my answer prior to making this video, so I know that works. You should do this with every single value. It's a fast way to make sure that you did not make a mistake. Thanks for joining me. Make sure to subscribe. Till next time, remember, you've got this.